For t greater than 0, the path of a particle is determined by the parametric equation x is equal to t plus 2 over t and y is equal to 3t squared. We are asked for x and y when the velocity of the particle in the x direction is equal to 0. Now we may choose to write x as t plus 2t to the negative 1 to make the derivative easier. We will get 1 plus 2 times negative 1 t to the negative 2, which can be written as 1 minus 2 over t squared. Now we will set our expression equal to 0, which means 1 minus 2 over t squared is equal to 0. Transposing 1 is equal to 2 over t squared. And after cross multiplication, t squared is equal to 2, which means taking the square root of both sides, t is equal to plus or minus square root of 2. We will keep square root of 2 because the time must be greater than 0. T is equal to square root of 2. We'll reject the negative value. To get x and y, we'll substitute t back to the parametric equations, respectively x equal to t plus 2 over t. Replacing t by square root of 2, we get x is equal to square root of 2 plus 2 over square root of 2. And we'll just simplify this sum. So it's going to be, because square root of 2 is the common denominator, it's going to be 2 plus 2 over square root of 2, which is 4 over square root of 2. Rationalize the whole thing. We'll get x equal to 4 square root of 2 divided by 2. Right? Square root of 2 times square root of 2, which will be 2. Ultimately, and when we divide by 2, we'll get x equal to 2 square root of 2. We will do the same thing for y, but y is a lot easier. Y is 3 times square root of 2 squared. 3 times square root of 2 squared. Therefore, y will be equal to 3 times 2, which is 6. So at the point t equal to square root of 2, this is our conclusion, xy will be equal to 2 square root of 2, 6. For b, they want the derivative of y with respect to x when t is equal to 1. The formula says the derivative of y with respect to x will be equal to the derivative of y with respect to t divided by the derivative of x with respect to t, using the chain rule. So the derivative of y with respect to t will be 6 times t to the 2 minus 1, which is 6 times t. The derivative of y with respect to x will be 6t divided by the derivative of x with respect to t, which we found earlier, 1 minus 2 over t squared. Now we just have to simplify. We're going to multiply the numerator and the denominator by t squared, which is the least common denominator. So dy dx is equal to, we multiply by the least common denominator, which is t squared. So it's going to be 6t multiplied by t squared, and 1 minus 2 over t squared multiplied by t squared. It'll be 6t cubed divided by distribution t squared minus 2. The t squared cancel. Now, we know that t is equal to 1. Therefore, dy dx will be equal to 6 times t cubed. T will take the value of 1 divided by 1 squared minus 2, which is 6 divided by 1 minus 2, which is negative 1. So the velocity of the particle in the direction of y is equal to negative 6. Now for C, we're being asked to find the second derivative of y with respect to x. Now the inner function dy dx was already found. We need to just manipulate it a little bit to make it easier to derive. So it's gonna be 6t cubed divided by t squared minus 2, as previously found. And dx dt is t squared minus 2 over t squared. Therefore, we'll get the derivative with respect to t of 6t cubed divided by t squared minus 2 over t squared minus 2 dx dt t squared minus 2 divided by t squared. Now this is of the form u over v, which is u prime v. U prime is 18 t squared times v, the denominator, t squared minus 2 minus u 6t cubed times v prime, which is 2t. The whole thing is divided by v squared, which is t minus 2 squared, divided by dx dt, and dx dt is t squared minus 2 over t squared. Clean up the mess. Distribute 18t to the fourth minus 36t squared minus 12t to the fourth. The whole thing is divided by t squared minus 2 squared over the longer fraction bar t squared minus 2 divided by t squared. Can simplify the numerator. 18 minus 12 will be 6. So it's 6t to the fourth minus 36t squared over t squared minus 2 squared. I'm just going to multiply by the reciprocal of the denominator, make my life easier. It's going to be multiplied by t squared over parentheses t squared minus 2. T squared minus 2. Now, the second derivative of y with respect to x will be 6t to the fourth minus 36t squared times t squared, and we add the exponent for the denominator, divided by t squared minus 2 to the third. When y is equal to 12, since y is equal to 3t squared, we will substitute 12 for y and solve the equation for t. We'll get 12 is equal to 3t squared divided by 3 will be t squared is equal to 4, and supposedly t should be equal to plus or minus 2, but t is positive, so t is equal to positive 2. Students should remember that t is the time and it's greater than 0. Now it becomes a simple arithmetic problem where we just have to replace t by 2 in the second derivative. So the second derivative will be equal to, open parenthesis, 6 times 2 to the fourth minus 32 times 2 to the second, close the parenthesis, times 2 to the fourth. The whole thing is divided by, open up parenthesis, 2 to the second minus 2, close parenthesis, to the third. We're going to solve this. At this point, this can be solved with your calculator, but we'll do it manually. It's going to be 6 times 2 to the fourth, which is 16, minus 36 times 2 to the second, which is 4. The whole thing is multiplied by 4, divided by 2 to the fourth is 4. 4 minus 2 is 2. So 2 to the third. And 2 to the third is 8. After we simplified by 4, we're going to have the whole thing divided by 2. 6 times 16 minus 36 times 4. We can divide each of the term by 2. 6 divided by 2 is 3. 3 times 16. And 4 divided by 2 is 2. 36 times 2. 3 times 16 will be 48. 3 times 16 is 48. Minus 36 times 2 is 72. And 48 minus 72 is negative 24. And the problem is solved. Here's a picture of the solution of all 3 parts of the problem. Good luck.